Okay, only 5 of you. Okay, all right. So when we say working software, I have a bigger picture in mind, and that means that what I'm actually doing as a developer aligns very closely with the actual real need of the business, so that when I'm done, real value has been generated. So if I want to do both of those things, and I want to do that really fast, continuously, and in a way that's sustainable, I have a kind of a tension here. And what's the tension? What's hard about doing both of these things in software? Yeah, when you're in a hurry, you have a tendency to take shortcuts, and shortcuts usually mean bugs. So usually, the desire to quickly iterate and respond to change would work against the quality software, the working software that we're trying to deliver. There was another point I had that I wanted to talk about there, but it's escaped me, so I'm going to keep moving. All right, so in order to deliver on this goal, I am going to argue that it absolutely requires automated testing and other automated processes, that there is no other way to really deliver on the Agile philosophy if you do not automate your testing and delivery process. And here's why. Because this is what coding looks like. In your first iteration, it's a lot of new code, right? And if we're manually testing things and we're manually reviewing code, that's sustainable. But at every iteration, there's a significant amount of code that is no longer being looked at, right? How many of you really go back in the application and test every piece of functionality manually when you've just finished a 2-week sprint? Nobody should raise their hand, right? Unless this is like your second, you've got a small project and this is your second sprint, right? It's not possible. The applications grow too quickly. The prior code so quickly outpaces the new code that there's no way to do it. And for you people who operate in a context where your developers are not writing your tests and you're relying on your QA people, it's impossible for them to keep up, right? First of all, do you have more developers or QA on your team? So they're already at a loss, right? You got all the developers writing the code, and they're already, just in a single sprint, there's already a challenge of quantity there that's difficult for them to keep up with. So the reality is, what's the reality? If you don't do automated processes, if you don't have automated tests, what's the reality for a project? Does it get tested well? It doesn't. And you've got your people who can test things like usability, who can test things like user experience, who can test things that the computers simply can't test. You've got them doing automated things that the computers can do, right? So every time I like to use the idea of assets and expenditures. If you're doing manual testing, your developers, right? Because most developers are not going to code something and then ship it without testing it, right? They're going to manually test it. Now, I understand sometimes things accidentally get pushed to production without getting tested, right? But for the most part, we're trying to be good developers. We're trying to at least test what we've done manually at a development station or on a QA server or something. So we're already spending time testing. What do you think for an average sprint? How much time do you think that the developer is actually working on a project? How much of their time do you think is spent testing code versus actually coding it into the editor? You think less than 1% of your time is spent coding, testing for most people. Any other guesses? 25? My gut is something like 25 to 50. Now that may be because I'm more of a thinker and maybe a little bit slower of a typer, but usually I'm thinking about what I want to do, I'm making a little change and I'm testing it, and then I'm making another little change and I'm testing it, right? So I'm frequently going back and testing, and if that testing process is complicated, like if I've got a contact us form, it's no problem to keep that open in my browser and just refresh things until it works, right? But what if I've got a 4-page form with multiple fields on each page, and the specific feature I'm trying to cover is on the 3rd page on the very last field? Right? How many times can I iterate on testing that? It's really very few, right? And if it's complicated, I really need to. And if I've got the time, I'm going to do it. But how much time have I just spent as an expense on testing what could end up being like a 3 or 4 line code change? Do you see how the ratios begin to stack up? Now, if I have automated tests, every automated test that I write is not an expense, but a what? It's an asset, because I can take that, it's an investment, and I can take a computer's time is much less valuable than a developer's time, and I can have a computer execute on that and make sure that the code is running well. So, yeah, okay. Sorry, I expected that slide to be before this. So going a little bit into our process as a development team, this is probably familiar to many of you. We develop on GitHub. All our repos are on GitHub. Our development goes onto a Git branch. We prefer smaller branches, smaller feature branches, smaller bug fix branches as possible, because that makes the code review that we do easier. It has to go through a pull request for a merge. The pull requests, or, well, I guess before that, the tests for the code need to validate. The test suite needs to run. We need to validate that code coverage has not decreased. And eventually, I'd like to get to a place where we can do a one-click deploy, but that's not there now. And so if we're doing this without any kind of automation, this is really hard. Why? Because as a developer, I've got to pull the code from GitHub. I've got to get my development environment set up if there's any changes to dependencies. I have to execute all the tests so that I can wait for code coverage, and that's before, well, I guess I could review the code first, and then I have to execute the test and run. If you're in a project where the tests take a while to run, like we've got one that project I said earlier that has like 8,300 tests, unfortunately the automated tests take like 40 minutes to run these days. We need to clean it up. That's not ideal. And when the developers are running them, they narrow in, and so they don't run the whole test suite. But our process is the whole test suite needs to run before you merge code into master. And so for that project, it becomes even impossible for the developer to do that, right? So if we didn't have a continuous integration environment set up, I wouldn't, as a business owner, I would not be able to tell my team, you must run, all tests must pass on every single branch, because they would simply come back and say, look, it takes me 40 minutes to run all these tests. I just can't do it, right? At which point we probably would have cleaned up the tests and run them in a more parallel fashion. But still, even then, if you split it into four, you're running 10 minutes each for each test run, which isn't ideal. So if you're doing all this stuff manually, this is essentially what you're doing. You're taking, I'm assuming that this guy is a developer here. You're taking a good developer that you're paying a high salary, and you're basically making him hold up a process, spend time holding up a process that's really manual, and this gets really old really quick. What do you think happens to your development team if you've got a process that's very manual and tedious? They leave. What else? They get off their game. I think this is true. It doesn't happen, right? It simply doesn't happen. Because what happens? The need for features come out, the need for bug fixes come out, and that stuff, that pressure as an organization, as a team, begins to override what the team has said is important, which is following this process. This, however, is productive. So this is unproductive. This is productive. And by this, I mean that in a pull request, based on the continuation that we have multiple things going on. Most of you are familiar with this. This is a GitHub pull request. In this pull request, we can see the conversation relating to the change. We can look at the commits. We can look at the files change, which is all GitHub. This doesn't have anything to do with continuous integration. But if you look down a little bit further, you'll see that we have a comment here from CodeCove that has the code coverage for the current branch, as well as the code coverage for the diff, which is really, really helpful, and I'll talk about that. You'll also see at the bottom here that you can see that Circle CI, our continuous integration, has passed. My continuous integration is set up to run all of our tests, so I know that all of my tests have passed, and code coverage contributing then again at the bottom. This is really important because for the workflow that we've set up, my developers have absolutely no excuse for not following the workflow that we've identified as being important. It's all there. Everything that they're supposed to do is there. They can review the code. They can make sure the test ran. They can make sure that the code coverage hasn't had a regression. They can look at the comments, and it's all in one place. How much easier is this than a manual process that they've got to pull down code and run the tests themselves? Do you think that with something like this, we're much more likely to not get into a situation where people start dropping the ball? I do, because I've seen it happen. So really, this is more than a process that I'm talking about. This is about culture. This is about me, particularly as a business owner or as a manager of a group, of a team, or if you've got a team that's self-organizing the team as a whole. coming along and saying, in a sense, we're going to put our time and our money where our mouth is. We say testing is important. We say that continuous integration is important, or we say that code coverage is important. But I was running into a situation where I was saying these things, and yet when I was asking the developers if they were happening, they were saying, sometimes, right? And it probably meant not a whole lot, right? Because they were busy getting the code pushed out, and they didn't want to get bogged in the manual processes. So I had my ears open. I said, you know what? Okay, I get it. As a developer, I realize in that situation, I don't want to wait 40 minutes for these tests to pass either. I could go work on a different project, but it's slowing my machine down, right? It's just annoying. So I want to build a culture that has processes in place to do for me what I say is important. And what I say is important is delivering high quality software really quickly. And so the more I automate, the more I can ensure quality and iterate quickly. As I get into the talk some, I realize that coming into something like this, especially as I get into the different layers that are involved, I'm going to pull in a lot of different things, and there's a sense of technology fatigue, which I think is real. How many people in here are full stack developers? Okay, maybe half. How many of you also do some kind of DevOps or sysadmin stuff? Most of you. Okay, so what that means is that there's a lot of technologies, and the reality is real that it's really hard to keep up with all that stuff. It's hard to do it all really good. And so as I get into this, I just want to acknowledge that that's true. And sometimes you can go to these talks and you kind of wonder, what's the real implications of this? What's the real practicality? Does this really matter? Of all the things I could put my reading and playtime into, is this something that I should really consider? And I want to say, yes, it is. As a business owner, as a developer, I love this. I love automated tests. I love continuous integration. I love the level of confidence that it gives me when I'm trying to work quickly for the customer. This is absolutely worth it. One of the things you're going to run into is that as you try to set up continuous integration, you're going to run into a lot of problems, probably. It has a tendency to take all the difficult things that you've run into setting up your own machine and like multiply them, because you have less control, or you need to figure out how to script the control. And so it can be really frustrating as you try to get into this. Like, I remember for a couple of days just trying to get one thing right in the whole kind of Docker setup, and it was like, this shouldn't take this long. It should. It should take a couple days to set up a continuous integration process that's going to pay 1,000% dividend, right? Just think about it in that terms. Once you get this set up, it's going to pay for itself over and over and over and over and over again. Even if you're in a team that really doesn't believe in this and you're like, man, I could set this up at my, in my playtime at night, absolutely worth it. Get it set up, show them the value, and you will see people become believers really quickly. So my suggestion is if you're going to embark on this process, start with constant incremental improvements. Do it in layers. Start with the first layer, automate the first layer, get that working in a continuous integration environment. If you don't have all the other stuff, that's fine, that's great, doesn't matter. Get one layer working. And then the next time you get time to invest in it, get the next layer. And hopefully convince your team, convince your boss, do whatever you got to do, that after the first couple of layers are in, say, hey, this is probably worth some work time, don't you think, to make this more robust, and then you're not having to do it on your own anymore. So once this is working, people will kind of pipe up and they see, oh wow, this actually works. This is nice. I get a pull request and I can see code coverage, and I see all my tests are passing. Like, why wouldn't I do this, right? So you quickly kind of make that transition. So speaking of layers now, I'm going to go into a brief summary of the different layers that are involved in that PyCalc 2 project. These are the layers of continuous integration. This is what I had to do to get it running. And a lot of these layers actually can happen even on my machine. All the way through Docker, these are all things that I'm doing on my local machine, just kind of prepping the project to run in a somewhat of an independent environment, because that's basically what continuous integration is, right? It's just a different computer. All the things that are difficult about continuous integration are really usually getting the application or the project to kind of operate in that environment that's separate from the development machine, which you've iterated on to get all the things right, and is different from the QA machine and the production machines that you've iterated on. It needs to happen from the ground up. It needs to all kind of get set up, and that's the part that's hard. So if I have locally, I've prepped the project where it's very independent, then passing it off to CI should be very easy. And actually, you'll be really surprised at how easy the continuous integration is. And if you're not, I won't believe you. All right, so this is running. This is an example of running the project in a virtual environment. Py.test is just a test runner. If you're not familiar with it, you'll notice that my bash prompt there has a virtual environment. And all I'm showing here is that typically this is what running tests look like for a developer, right? I've got my virtual environment set up. I've got my test runner. I've got my project, and I'm running the tests, and I'm hopeful that they pass. If I was a really good slide writer, I'd have the 38 passed in 0.12 seconds in green, like PyTest does, because that would be really cool and make me feel good. I love seeing the green text at the very bottom, but I couldn't figure out how to do that fast enough, and I was already late on getting the slides done, so I didn't do it. But the other thing that we do is Flake 8. I don't know if you guys enforce code formatting standards. I like that because as a developer, even though I don't agree with some of the formatting, it frees me from the question of, I wonder which way I format this today, everybody else is kind of stuck with the same rules. So it makes it easy. You can integrate this into your editor so that you can see when your linting doesn't work. And we actually make this part of continuous integration. So this is why I have this up here. If our Flake 8 fails, you actually failed the build. So we're pretty. Once again, this is part of culture, right? If I say conformance with Flake 8 is important, I want to enforce it, right? Because otherwise, what's going to happen? It's just not going to get followed, right? Eventually, I'm going to do it. I'm going to pull up a file in my editor. I'm going to get like 18 squiggly lines, and I only need to change one, and I'm just like, I don't want to deal with this. And so your culture, because it's not enforced, feels free to just kind of let it go, and it bit rots, if you will, and I don't want to do that. This is just an example of running with the code coverage analysis so that you can see what it would be like to put code coverage into this project. And the whole point of all those last slides were just to demonstrate that the first thing that needs to happen for continuous integration is whatever you want to run in continuous integration needs to run locally well. Second thing is dependencies. Dependencies are a bane of our existence for any project. Getting them right, the right versions installed is really important. We use a process called a wheelhouse, or this is, everybody's familiar, hopefully everybody's familiar with wheels. If not, you can look it up. But wheels are kind of compiled Python packages. And what we do is we actually end up producing all those wheels, building all those wheels, and committing them in with the project so that we're never dependent on a network resource to pull in our dependencies. And at any given time, the developers can go in there and see what's in that folder, and they know what the project's supposed to be running on. That's opposed to pinning our requirements files, which I find advantageous because I often find that those pins get out of date. And so the way that we have this all set up is basically that we instruct pip to install from this wheelhouse directory, and we let it install all the latest packages. So getting the latest package basically means building the latest wheel for whatever project that you want, and then pointing pip at the wheelhouse and saying install the latest packages. So that works really well for us. There's a project out on GitHub under level 12 wheelhouse that has a README that explains all of this. I really, really like it, and if you have problems with managing your dependencies, I'd encourage you to read that, and if you got questions, reach out to me and I'll tell you more. But this is how we manage our dependencies, the point being that all of our dependencies are there, and this also helps our continuous integration and our developers because we treat our virtual environments as temporary. You shouldn't have a virtual environment that sticks around. It should always be temporary. And by doing that, you can make sure that your process of loading your virtual environment with the current dependencies works for developers. And then what do you do in CI? You just follow the exact same process. So if your developers are in a situation where they need to pull out a project, they start the project, they load the dependencies, whatever process they've just used is exactly what you can use in continuous integration. So I hope you see that the whole process that we're building is kind of like we're treating every environment like continuous integration. It needs to be really easy to start with the source code and build an environment that will run your application. Next is tox. So now that I can run my local commands to do what I want to do in CI, and I know how to install my dependencies to create the Python environment so that it runs. now I want to add Tox to the mix so that I no longer need to have a virtual environment, that I can, from a single command outside a virtual environment, get all of my tests to run. Tox summary, for those who don't know, Tox is going to create a virtual environment. It's going to install all my dependencies from the wheelhouse. It's going to run the tests with coverage. It's then going to run Flake 8 as the linter. And if any of these things fail with non-zero exit codes, that's going to make its way all the way back to Tox. And Tox is going to exit with a non-zero exit code, which is really important on our continuous integration, because that's how the continuous integration server decides if your builds have passed or failed, is whether or not the commands that you run exit with error codes. So this is an example of Tox. I'm not going to really go into this. I prepared this slide a little bit for some people who maybe were not as familiar with Python. But basically, the gist is that Tox does the same thing that I showed in that first slide that ran PyTests. It runs my Python tests here. It runs Flake 8. They both pass, and I'm done. With maybe just the reminder being that Tox is setting up a virtual environment for the Python environment based on what we have installed in the wheelhouse. Toxa, INI, all those types of stuff are out in that PyCalc 2 project if you want to see details on how we set this up. So the difficulty now is we used to actually run, that's all we did for CIs. We just ran Tox on the CI server. We started to have some issues with, when we started including like JPEG libraries and stuff, we had issues where on the developers' machines, we already had the Linux development package of live JPEG and the Python dev libraries. Actually, that wouldn't matter, but some other libraries, we needed the dev packages. And so we would have stuff that would run on the developers' machines, but then we'd pipe it to CI and it would break. And it wasn't because the tests were wrong. It was just that, once again, the environment wasn't the same. So enter Docker, right? I can put all this in a Docker container, and I can make sure that the container that I'm running as a developer is the exact same container that I'm running on the continuous integration server, and it just kind of works once you get it set up, of course. So at the heart of our Docker run, the Docker run test script is in that PyCalc 2 project. At the heart of this Docker run test is basically just a Docker run command. We're mapping some directories. This is the source directory to a volume. This is the source directory of the code. We're going to write some tests. Some of our code coverage artifacts and stuff is going to get written outside of the container so that we can pick that up later and pass it off to CodeCove. Some Docker flags. I won't go into that now. This script has got some more stuff in it. You can see why we use that. But then we're just pulling the Python test multi-container, which we've got out there and building on Docker Hub, and it's basically just making sure that all of our environment is set up correctly. Okay, so now this script is designed. You'll see this is really kind of the last bottom 5 or 6 lines. There's a bunch of setup above this script, in the script, that basically takes figures out if you're in a CI environment or figures out if you're in a local developer environment, and then sets these variables accordingly, right? Because in a local developer environment, I'm going to pull the source from a different location than I'm going to pull it if I'm in CI. So with the idea being that this single script can be ran by either CI or by the developer, and it's the same every time, right? It's just run the script, let the script take care of deciding on the things that are different in the environment. So now, continuous integration, actually moving this to a continuous integration service. The big continuous integration service that everybody knows about because of GitHub is Travis CI, so you may be familiar with that. For us, we started with Shippable because they had good Docker support, but then we had other problems with them. We moved to Circle CI, and we are very thrilled with it. Circle CI works fantastically. They're fast builds. They've got good support. So if you're looking for a CI solution, I highly recommend them, and they're not very expensive. And I get no affiliate fee, I promise. So this is it. CI is simple, right? This is my circleci.yaml file, or circle.yaml file, whichever one it is. This is it. I asked them to make sure that the Docker service is on that machine and running, and then this is my test command. The Circle project repo name is the source where they are checking out the GitHub project, and then that Docker run test is the same script that I showed you earlier. This is it. That's all there is to it. And CI is running. Obviously, the work that we did beforehand to get our project set up in such a way that we could run it in any environment is the key. So once we have CI running, now we want to move to code coverage. Once again, I said I'm big. My team is big on automated testing. Most of our projects have over 90% test coverage. Our two biggest projects are in the 95% range, which I think for a company that's doing contract software development for customers who want features now, I feel like that's pretty good. As I ask people who are out there, I rarely get people who have good test coverage at all, and usually I'm seeing, for the people that are trying, there's like 50 to 75%. So that's not to toot my own horn, that's to say that we really can serve business customers who primarily care about features and still do good automated testing and continuous integration. They're not at odds. It really isn't an issue of I don't have time. It's really an issue of do I have the culture and the processes that support this? Okay, so if you remember, or actually this first snippet is from the tox.ini file. You'll see that I'm just passing in some variables in order to get it to do code coverage while it runs the tests. This is key. I'm telling it to write out the JUnit XML file, which has all the code coverage information in it, to a directory. I don't know, this you may not have noticed earlier, but this .ci test reports actually gets is one of the volumes that we map in Docker. So this gets mapped outside the Docker container to a file, to a folder directory that's actually accessible to the CI machine, the Circle CI machine. So if I list that directory, obviously the file is sitting there. And then I lied a little bit on the last slide. There actually is one more section to that circle.yaml file. Sorry. Yeah, I did. Unfortunately, it's not me. You want to wiggle it over there, see if that helps at all? Sorry. So this last command here is basically pulling down the script that CodeCov gives us in order to load code coverage analysis. You simply run it through a bash command, which I'm not real excited about, but I trust them with all the code, so I suppose I can trust them with running their script. And I pass a token. The token is obviously going to be project specific so that it gets the code coverage to the right project. This command will actually kind of search through all accepted, and that's a culture thing. And so you know what happens when a build breaks? The developers go fix it as part of the project. And it's not like days later or weeks later. It's like the same day, sometimes within minutes. And that's really helpful for the developer because they haven't moved on to some other project and they aren't, up to their knees in, whatever the next bug fix was. So we got Slack and we got GitHub integration. So now I'm at questions. Anybody have questions about how this might apply to you or real world type stuff or whatever?
Do you enforce documentation anyhow through this process?
No, we do not enforce documentation. So in fact, to be honest with you, we don't write a whole lot with this stuff really works. Bring them to this. If you've got people, the holdouts, figure out who the important holdouts are. Now you've got, whether you like it or not, you've got hierarchy in your team. You've got people at the top and you've got people at the bottom. If you've got a holdout at the bottom and they don't carry a lot of weight, don't spend your time on them. Spend your time on trying to get the person at the top, because if you get them convinced, that's gonna roll downhill. That doesn't mean you discount the person at the bottom, but if you got 3 people at the bottom and they all are for tests, but you got one rock star developer at the top, and that's who management listens to, you're barking up the wrong tree.
I have a team that views code coverage as nothing but a vanity metric. How do you kind of help that along, and where have you seen diminishing returns? Obviously, 100% code coverage is not necessarily any significant amount more valuable than maybe 80%.
So the question is, he's got a team who sees code coverage most as vanity metrics, and so what was actually the question?
So how do you sort of change
How do you address that viewpoint?
where do you see diminishing returns?
Okay, how do you address that viewpoint, and where do you see diminishing returns? So let me ask you this about your team. What do they think about testing? Automated testing.
So we have a lot of legacy code, and we've finally overcome that hurdle of writing tests.
A lot of legacy code. So they do believe in writing tests first?
Yes.
Okay, so I would say from that, I would try to emphasize in the culture of the team that we write tests because we value working software, right? And so if we're going to spend the time to write tests, don't we want to know what actually has test coverage, right? Like if I'm working on a module, isn't it actually helpful to realize that I've got a test that's missed, the second predicate in the if-else statement, right? Like I don't have anything covering it. So as you're trying to build this culture of we try to test everything, which I guess I'll address in your second question, then you can start asking the question, how do I know if I've tested everything? And code coverage is a good, not the only, but a good metric for that. So code coverage becomes a tool to measure how well you actually covered your code. So if you value as a culture getting all your code covered by tests, then you should value the tool of code coverage to tell you where you're missing test coverage. The second question was, where is the point of diminishing returns? I actually have talked elsewhere about what I actually promote is this idea of test-centric development, which means I go into it assuming I'm going to test everything. And I don't necessarily mean automated tests. I mean, as a developer, I should be testing everything that I write. And then I bring in this idea of asset versus expense, and that hopefully in the culture starts to build the realization that, wow, I'm testing this stuff anyway, why don't I write the tests and let the computer test it for me in the future? So now, test coverage, how much of my code is covered by tests, once again just becomes kind of this duh moment where you realize most of my time probably should be spent as investment rather than expense. And so as you begin to work on that, you begin to realize that, most of your most of your code should be covered by tests, and the 90 to 95 percentile really does add value beyond the 80. That 5 or 10% that you're not covering, absolutely. Sometimes you get into something, you just realize this is not worth the time that it's going to take for us to cover that. We do that right now with a lot of our JavaScript stuff. We've only got one project that has integrated Jasmine and Selenium tests to do the JavaScript testing. So for us, it kind of it works in a concentric circle. If you've got code that's touched by a lot of stuff, you have no excuse for not testing it. We're going to look at the code coverage. We're going to say, look, your diff was only 75%. Why didn't you get the rest of that covered? This is a core feature. Go cover it. It's not going to get passed. If you've got a view, HTML view, and you've realized that, oh, you know what, I actually didn't test both cases there, but for whatever reason, it's going to take me 3 hours to do it, and it's only taken me half an hour to do what I've got so far, you can probably make that justification in the pull request and just say, I think this is something we could probably skip. And then it's at least but it's still the idea for the culture's purposes is that code coverage diff at least brings it up in discussion of why did you decide that this wasn't worth getting code coverage on.
How do you manage if you do a big feature and the tests would drastically change? Is it just an investment you think into it?
How do you do a big feature and your test would break, right? So what do you do with the fact that the tests break? Absolutely, right? Like if you're going to do a big feature, you want tests that cover that big feature, right? And the tests that no longer are valid because the code has changed, they need to get cleaned up, right? Because your tests, in my environment, in my culture, your tests always pass. Your tests are always your tests are your. It's like your trying to think of a military term where you got kind of a backup team, right? Like they got your back, right? Your tests are what's helping you as a developer get in there, get my tests or get my current whatever's currently in view done, whether it's a bug fix or feature, and then get out and not worry about all the other stuff that I might have broke. How many times for the people who don't have good test coverage do you actually go do the problem, but then you spend time kind of thinking about, okay, what else might I have accidentally broken here? There's a lot of mental overhead there. I don't want the developers to have any of that mental overhead. I want them to get in there, get their stuff done, get out, and assume that the tests are going to cover anything that they weren't aware of.
Can you talk a little bit more about the pinning? You said you were not using pinning requirements.
Yeah, if it's all right, I'll get with you after that since that's kind of tangential to this, and then we'll be happy to discuss. Okay, equal parts Python and Python and JavaScript for the project.
Yeah, my problem is I have a lot of tests in Python that run Selenium.
Yep.
On a Chrome.
Yep.
My problem
Yeah, so what I would encourage you to do is check out the headless browsers. Anybody tell me what one is? I forget. Phantom.js, I think, is one of them. And see if you can get that working. And if you can, then that basically means you don't actually need to spin up the browser or the GUI. It'll kind of run all internally with a headless. And so I think that's how we're doing it. Bill, in here. Is that how we do it? Also, AppVeyor, which is a continuous integration environment, may have a feature for running the browsers, running Selenium with actual Chrome and Firefox. Other questions? Anybody? How do you ensure the quality tests are being written? So tests are just other development code, or just code, and so they get quality verified just like anything else, which is basically you're trusting your developers to write good code, and you're trusting a code review process to catch any of the big stuff. And when you find that there's bugs in your tests, you fix those too. The point being, it's not any different than the other code. You just you develop once again a culture of treating your tests as first-class citizens. Whatever level of quality you would put into the code, that's the production code, the code that's the feature, that's the same level of quality you put in the test. Tests are not a second-class citizen. Okay, that's my time. If you have any questions, please feel free to catch me afterwards. I love talking about this stuff.